Hello and welcome back. So, last time, uh, if you check the previous videos, if you're just joining us, we've finished with the creating the core and the cavity and also all the components needed for the injection system. So, next we are going to move over to the injection side to start placing the components needed for the injection of the parts. So, you can move over to hide this and turn on all the injection components. So it just need cavity plate B from B plate all the way to bottom plates. So the first we are going to do, like we did for the injection side, is to create the screw that holds the cavity insert and the cavity plates. So you can hide. We will move this for now. I want to create it on this plane. That's where the screw stops. Oh, sorry. That's actually the support plates, not the main cavity plates. So by the support plates here, this is the main cavity plates. So I'm going to create the screws that will hold it in place. So the first thing we have to create the points. We already have a layout sketch for the cavity plates, the screw holes for the cavity plates. So I just move the fact to project those points, make sure it's on, with the dot on. You can find this. Let me hide the main plates, the main cavity insert here. So these are the points. So you must project them. So the points is for both the screws and door pins. And then from this record, turn on, please click on, well, you may prefer to use the iron fasteners. But the utilities, make sure the iron fasteners is running. So we'll need comb. That's where we selected socket SP faucets. And yeah, so the price is just the same with the one for the other. So now to put an M squared screw minus 80. Ah, 50 will be good. My unit is already 30 millimeters, so I don't need to input any units there. The thread length. What for to do is computations and see if it's created the screw in the correct position. So it didn't create it at the correct position, so we have to flip all of them. Put it the way it's supposed to be. Now let me do this last one first. It's in view. Also flip minus 12. So do it for the remaining four. So we are done placing them in the correct position, as you can see. So the next is we are going to insert the door pins. The door pins, select the points. For this one, we can't create the 4 at a time, so we have to pick it 1 1. Sorry, it's supposed to be X12. Then top 80 mm. Things are beginning to slow down because our memory we have we have lots of design timeline already, so things might begin to slow down a bit, but let's continue. So we've done that. We'll do it for the fourth deck. Now, let's do fifth one. Uh, just a bit of information. When I'm done, this design will be made available on GrabCAD for free. So you can download the complete mode design for free on GrabCAD. We place the link will be placed in the description, so you can download it and take a view for yourself of the complete design. Also, uh, that's not supposed to be made available both Fusion 360 format and SolidWorks formats. Yeah. So you can download anyone you prefer. Now we are done fitting the four door pins. So now let's do a good session view to see how well the screw engages the components. Before we, yeah, can see there's a depth of which the screw engages the components. Let's see if we can still view the door pin. Yeah, so that's the door pin over there. And it engages the two components together. So let's combine them to do a combine operation so the rules can be created. We'll expand this, expand this, expand this. You can select I need to activate key tools for this one. I can select door pins from the window, directly from the window. That's opening the browser. So go over let this one. Over this one. I was supposed to have 12 number total bodies. Okay. And you can hide just let's cut the cavity inside as well. Before we hide our bodies. Yeah, this way started from inside of this one. So this one, so this one, and now this one. And go over to select the door pins. And this one, select this one. Select this one. And select this one. Okay. So we can hide the bodies. You can remove them if you have the time. Have the time to remove them because they are not needed in the both for the designer or the manufacturer. So we are done with that. So the next thing is to create the main screws that will hold all the ejection sides together. So for that, we need to return one back all the plates at the back. So for that, we need gearing fasteners. We install the first set again. There's point, dot point, dot points. The grand definition system. Let's let's go calculate the total length excuse me, the total length of screw is going to be sufficient enough. So let's move to inspect commands, inspect this, and then you need to load up the Let's really up to there, a bit above the support plates. So let's hide this place is plain here. So we can use this place here. So that's 3 bits. So we need something above. We will need something above 3 bits. So let's see if we have the if we can get screen above balance. Mediums. Socket has good process. Minus 74 points. And something. Yeah, so the highest we have is 300. I don't think that's even standard for 1020 screw. So you said M20 screw, we must have the screw length must be 200 or less than 200. So we have to make some adjustments within more days. So the best we can do is to reduce the thickness of the support plates. So let's check how thick the support plate is. 136. Yeah, so we can reduce this. So according to the Haskell mode based standard, uh, they have a plate of this size that is 36 mm. So since this is 136, we can reduce this to 36 mm. So we select that plane. So this would be 1 minus 136 plus minus 136 plus 36. It's a cut operation, of course. So if you do that, then you need to take this downwards. The distance to move was 1. Yeah, it's facing the other direction, so it's supposed to be negative. Minus 136 plus 36. Okay, we zoom in to check if we have any interference. Seems to be on the correct point. So now let's inspect this again and see if anything if the screw of 200 mm can work. Yeah, so can still work this to 18 mm. So, but the thing is, it can put all the way from the bottom plate to the support plates. So what we're going to do is we put a screw that will hold the bottom plates and all the way to the support plates. Then the support plates also create another screw that will hold the support plate and the main plate together. So that together, all of them will be one rigid group. Or you can just move along with me if you don't get what I just said. So let's continue. You understand it when I don't what's that 218? I think 218. Yes. Yeah. So but before we check that, let's discover the mistake. As you can see in my browser, it didn't turn on the retainer plates. So that simply means we didn't move the retainer plates. So and that means the retainer plate is in a very wrong position. So M for move, let's correct that real quick. Supposed to be components, not bodies. So select the retainer plates. This time same thing. This time the direction is facing downwards. Supposed to merge with the ejector plates, and then we have its capture position. And so that's corrected. We can move over to checking the amount the depth of screw we need. So let's go from here to here, 182 mm. So we need something just a bit above that. Let's go back to our diamond fasteners. Software test 4 sets. Let's have the points. First, perform, third, first, and 20. No, so that's the no, huge small pixel contrast. So that's the whereas we have your length should be 150 thread length. Let's go to the let's go let's go at 67. So I should get exactly to enter the support list. Now let's do now we'll check to see how far that goes. Mm, so it's forward. So engages the nameplate a little bit, but that's not that's clean for place. You have to screw the support plates and the main cavity plate together because this can't put this template. So when I done fixing that, right the bottom plates, the two retainer plates. Mm, yes, there's probably nothing going to be around here. So I think we can fit it under this riser place. So let's hide the riser place. And we need to turn on our cooling line to make sure that it doesn't interfere with our cooling channel access. At this point, so the other point I'm not using it. So now let's look for petition to fit in the screws. Little clear sketch. So let's check the diameter of this page before. I think that I'm aligning to this place. I think it will be fine for me to align it with the main screw. Let's see what this is. This is quaternion default gadgets. The gadgets it is constructing reviews to Windows 60 mm at first in 0 degree. Internet and insert screw for this. And we can just new other points. Begin that's how we filling around. My new is to finish sketch. Can move over to the personal skill or create skills. Subject text to concepts. And for this one, will need a pencil, of course. Uh, it's 65. Um, that's this and mm, that's 65. About 30 mm. Okay. Now we wait to these complications. Not just need to put in line. We have to also have to another benefit of putting it on these pens. You don't have the issue of it interfering with you already laid out ejection points. So all of these it's created this on the wrong side. So okay, I have to make it and create it on the road and side is supposed to face. So this is -12. Let's see how far that's engaging the two components. Mm, mm, that's the door thing. How this area also is green. Yeah, there's a trend launch. Um, it should be okay for this. Also combine them together. When you can go back here to open them up. And now give my shortcuts. And shortcuts is not, I don't know why my shortcuts is not fast in fixing anyways. You have to combine my shortcuts to the starting. It's a very good point. Mm, two, three, four. Again, no associated again will be for the nameplates. Okay, and hide the bodies. So now we're done with that. I have to proceed further to placing the right bushes for the node. So go back to utilities, of course, right elements. We need us to guide bushes. That's where the four points. Learn method. 342. The length, it should be the same thickness as our node piece. Can't wait for it to do its computations. Now it's placed on the wrong side. Again, we have to flip it over. Uh, that means to click on, so it needs to go down and don't know the distance except and set it. So let's just control Z and select the points again. The red bushing school. No, I think it was the top points we selected, so let's select the bottom points this time. And maybe this time it will place it in the correct direction. 42 and place it. Let's for it to do this competition. To place it in the other direction. So if you have a big difference again, as it tries, that's no, it has to be wrong. It has to be wrong position. Let me just let's see. You have to check. Let's see if we're actually selecting the correct calculations. So there's gonna be the problem. Like this place. No, it's the wrong one. I'm selecting the wrong calculation. That was causing the problem. So this would be this. Let's try it again. Uh, let's the feature updates. The major, as you can see here, the drawing. From the drawing, you see that it's correct. The correct one was supposed to use. So in feature updates, I'm going to differentiate the two guide cushions very differently. So you know the one the correct going to select. So Haskell has two different types of guide cushions. Yeah, so that's this perfectly now, so it's now. And the price will be it says the correct direction. So we have to turn on back. We need to turn in everything. Let's just turn on the guide glass to see if the dimension of the guide glass in to see if the dimension is selected with the correct one, but please the guide glass. Turn on the guide glass and do section analysis. Now to correct one, also fixing also into the cortex and in the mode base. So now I don't fixing the guide cushions and now the guide system is complete. I just move over to creating the cooling channel for the B side as well. You can decide to use some core cooling elements, but this for this the depth isn't that much. It's not really necessary to use core cooling. It's still be a very big process for you to use that. But for this, we're not going to use any core cooling components. And I selected everything Okay, and let's go back to hide the cooling line and do a section B to ensure that the cooling line is not interfering with anything. Mm, nice. I didn't combine the nameplates, and that's why I can't find the whole. Let's combine it again to really combine the packaging sets. And 1, 2, 3, 4, 5, and and now can use equal to the section B and even save the section B. Minus 3 minus 12, 12 9. Huh? Minus 10. Minus 11. Let's check. Wow, it's under that doesn't seem to. Doesn't seem to interfere with anything. Although I can't see the weapons from this angle and I can't see the is good. The main skill, so it doesn't interfere with anything. Okay, now let's save that section V. Mm, I don't want to edit. Now let's do fully line down. Yeah, so can you can turn it off. Now you have to create the pipe connectors for the cooling line. Uh, already explained previously, it's just they're just mirroring images of each other, both the cavity side and the core side. So I'm just going to create all of them to once and insert all of them. So use 4 plus 8. So you go to pipe connector, we need 10 pipe connectors and the diameter is 14 there. So let's just create the 10 of them quick. Use one. You can hit spacebar to repeat the previous commands. Or well, they just I think they just changed it. Although maybe I was online, they just made a new updates because previously spacebar was for the previous commands. So this is the second one. Talking what spacebar now means insert components. Right there. You don't want to learn a concept on that. So this how many have we created? 3. We need 10. The impact note of 4. Repeat again. 5. Mm, mm, 6. Another 7. Yes. 8. Yes, 9. 1. 10. So we have 10 of them. What I do, once you just go over your select this one, put down shifts. 10 for move. Make sure you are moving your components. Add them out. capture position. I'm going to join each of them individually to the all the points that need the pipe connector. Now, so I have to create the joints for the pipe logs. I think we need to hide the main, but first of all, we need to open this up so that the fastener can get in here to fit in the pipe plugs. So to do that, we just need to press pull it. So let's pull -3. Now, so the initial diameter was 14. So this is supposed to use 20. I think that will be enough for me to get the two so that we enter here and fasten this up. So that is actually hexagonal sockets. Hexagonal socket that fastener to be used. So just open it up now. So this is supposed to be 22. Yeah, I think that'll be enough. So let's expand the rest. The side diameter so we can select all of them together. -4. So I think when we combine this, the two inlets at the front, it didn't get to the tent, so we can extrude it to open it, hide the cavity bit. They can look for those two inlets. So we have the two inlets. So now is to get inside. Uh, you can't see inside, so let me just create a sketch and project it. Don't need a planar view. Project this one, project this one. So now I can shoot them out. Let's pull this one. It's -4. Okay. So now we can go ahead with fitting in the pipe logs. Mm. We need the B plates. What we need is the cavity B plates. So now, yes, our pipe logs, we created 20 of them already. So I'm just going to fit them to all the points, pipe connectors. I mean to say, I'm just going to fit them to all the points. Now, almost done. Just making the so at the front. I skipped for this one. The error was from the billing line, so the software is seeing it as not a perfect circular points. But just need to find a way and fit it in where. So let's take that and into 7. That way is not just 15. Ah, because diameter is 14. You just need to move with a distance of 7 from the end. from the endpoints. Yeah. So now we are done fitting the pipe plugs. We have to fit in the ceiling plugs so that the outlets coolant and the inlet coolant don't mess up together. So we use our section view, turn on back the section view we created initially. So we have a ceiling plug here and a ceiling plug here. So uh, the hot water coming from inside will mix with the inlet liquid. So you need to turn off the section view because it won't uh, allow us to see the visibility. So we've created it for further purpose. Still retain the selection. We need two of them. Let's do them at once. Go down and for move. Make sure you are moving the components and not a body or a surface. Okay. Now you can capture position. J for joints. Can pick one first. And go ahead and go back and turn the section view and supposed to be installed here. Supposed to face this way. Then we draw it in. Now that's okay there. Okay. Turn up the section view to pick the other one. Create for joints. Turn the section view back on. And the other one is supposed to be one error I just made is I snapped it to the pipe connector, and it's not meant to be like that. It's meant to be snapped to the plate as to the main cavity plates. Because at the end of the day, but it might not matter. It might not matter if you are reconcerning with who quiz this thing is going to be likely to be if it's to be manufactured. It should be exported in step formats, and if it's in step formats, all the joint details and the assembly details will be deleted, but they will still retain their original position. So only if maybe another engineer want to check something and expect something that he needs when he needs the assembly details, that's where that will have an issue. So I'm leaving that for now, but just taking note that's actually wrong. It's actually wrong. It's supposed to be snap to the cavity plates. Uh, let's move ahead. We're done with the cooling line. We're done completely with the cooling system, so we have to move over to the injection system. So control number calculates. So firstly, what I want to do is create the screws, the screw that holds the retainer plate and the injection plates together. So select our bottom plates, P for project. I need change selection. Since we don't really need that, since everything is at the origin. I can just use theta rectangle. So the longer side is 594. This this information is gotten from Haskell catalog. Like I said, if you purchase the full version, you get that for free. Upon request, you don't just submit it. You actually request it. You get it for free. Uh, if you read the points, 4 points. You need to be M2 exposed as well. Now, I'll finish and sketch. And let's press this. And we already have a glove, the length of screw we need. We'll move over back to, sorry about that, I mistakenly clicked another design. Wanted to move to utilities and the also went a bit upwards and picked a new design. Anyway, so let's go back to our fasteners. Select this corsets. M12 minus 50. Okay, I'll wait for it to do its computations. Created that the wrong point. Do the job of flipping it over again. I mean, this maybe in future updates of DIN partners, this issue will be fixed for sure. Uh, this issue will be fixed for sure, but it delays the time, slowing down our design time, but not that much duty. And the last one, that's the section view. Just see how is this. No, almost 2 weeks. So that's just enough. Now we have to combine them again. The two plates. B for combine. And select the cut bodies. Combine again. That's all the cut bodies. They are supposed to be dating under it's cut body. Now can hide the bodies. About fitting those two together. We can move on to creating the ejector pins. So you have to first know length of the ejector pins we need. No, I need to hide the ejector plates. Mm, the ejector plates. Hide this carefully, blocking the place and blocking of view. So let's see. We don't have any linear surface. We don't have any planar surface here, so let's create one for the highest point. I think this is the top. Yeah, this is the highest point. So let's see planar command this traits. Let's check. Mm, I need this view. The traits. Our traits. Okay. So now let's inspect from here and know the distance. No, I don't think except this is not straight. Since we can't get, don't recognize any distance. Okay, let's recognize the distance. So about 300. So we just go above that. So I've already created the points for the injector pins. So I'm going to project that onto our blades. If I project all of them on the rest one. Okay, now just have no one is left. Yeah, so once I knew we were missing one because we have two cavities, so definitely the number of projection points supposed to be an even number, and we're having 19 there. So now we also need to add one ejector pin for the screw puller. So when the thing is done, it's still need to help to push the runner and the gates out. So that's the work of that ejector pin at the middle. Now you are done creating all the points. We can hide this and start inputting the ejector pin. Go to ejection, select the points, need to let's go for 315. You can also, if you know the exact length, you can also input your value in the custom length and change the length. That length you move downwards to the bottom end and select custom length, and it's going to create the exact length you need. Yeah, I think that's enough. So we'll do it for the 10 or is it 20? No, 20. The 20 ejector pins. Because the one for the split puller is going to be a different length. I mean a different diameter and a different length as well. So we'll do for the 20 main ejector pins. So just like I did the screw, it's not in real mode design process, it's not supposed to be a guesswork. You're supposed to calculate the clamping force and so many other stuffs like that. Same also for the ejector pins. the bigger the ejector pin, you can use lesser amounts. And if you are using a very small one, uh, you use more amount of ejector pin. So this is just for demo purposes. It doesn't mean that this is actually the right diameter of ejector pin you're supposed to use. Same as well for the screw. Some of them, what we did, uh, it takes some calculations you need to put down before selecting the right screw. So it's not just you just select any length, any diameter you need. So you know the one that fits it perfectly. So this, as like I said, it's just for demo purposes. So you really understand, you really get how to use this admin for your design process intuition. Mm, but this one, and I don't we check again if the actually 20. And luckily for us, this one, the ejector pins just uh, seems to always face the correct direction. Mm, now if you are just joining this video, you are watching this episode for the first time, you might be asking why didn't I just do an area and fitting out doing that. I've said the reason in the previous video, so you can go and check that. The reason why we are doing it individual, we are not just creating an area and placing them there using joints. And so now we are done. We have to, is there any more remaining? These two. These two is remaining. Uh, let me do that. You can also confirm from the browser if that's one thing. And that. Mm, 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 mm. Yeah, things are beginning to slow down a bit. Of course, we've created lots of commands in our timeline. So I've said in the video I did on creating a hanger mode, close hanger mode, said one way you can override this is to export this file as step, then continue from where you stop. But the problem with that is if you want to go back and edit something, you cannot. But it's going to reduce the workload on the memory. So because lots will have much memory, particularly so particularly if you are designing very complex nodes where you're going to end up having lots and lots of hundreds of components. Um, that thing can be the method can be very useful, exporting it as step and just continue doing your work. So that completes that 20 number. So now let's create the ejector pin for the center point. This yellow, the yellow color is not making the other component visible. No, color is too bright, I think. Let's go for 3.5. You can still go for the same length, even if I know it's going to be much shorter than that. Yeah, there's our there's our uh, injector pin that we pull out the runner. So it's too long. I have to bring it down a bit. Let me check the distance from here to there so that's no harm by how much we are going to bring it down. That was 59.188. So we're going to go for 58.8 would be okay. Mm, 58.6. Yeah, so no, it's too long, it's too short. Need to shoot out the kids. No, let me say 0.3. Not join it to not to join a new body. So then I'll train it. Oh, sorry, that's not a good practice. Uh, do it in a more smarter and professional way. Edit picture and change the lens. Yes, 59.1. Uh, 0.7. Mm, look at all the bits. Evaluation time. English is just in. So I have to go back to our runner. Now you see if it's touching, it's just touching the runner. Mm, red button to the red button. So it's not touching the runner. So there are two ways you can do this. Either extend the runner to go down or extend the ejector pin. But the more smarter way to do it is to extend the ejector pin because you increasing the length of the runner is just basically you're adding more wasting material. And those costs, in terms of costs, is not that's not smart thing to do. Not smart thing to do. So let's go 3.8. Yeah, I think 4 would just be enough. Okay. Now, so on that thing, I need to close this up because if this is not closed up, plastic is going to flow in here and it will stop the ejector pin. So again, let's go press flowing. Remove one. And since this is tapered, uh, it need to be tapered as well to close that segment. So what I'm going to do is I'm just able to close everything totally, then use the combine operation to open the places that is necessary. Then of the session analysis. Then hide it back the running. Running. How to run so I think this is straight. You also should get these points. Oh, okay. our surface here no streets. Again, that should, that's what I need. Again, I should um, conserve these points. Oh, yes. Let's get the distance. Also, the issue we are having here is this place is not straight, so there's no way we can get we can enclose it and it's going to the profile is going to match with this round surface. So what we have to do is to use surface and patch it, patch as I will there. I can turn up the surface for now and use left to load it up. Let me hide the ejector pin. So it will be end up doing the board. Go back. Go back to the surface. Yeah, back to this one. Yeah, we need to be a join location. So that's good now then. I turn on back the runner. This I come down. The right side the runner. So that has been created then. To go back and turn on our ejector pin. So there's a section view to see what's how that is look like and turn on that the runner. And to turn this side. Turn the runner. And the left view. Now you see that's the ejector pin need to up a little bit. So I just go back to the command that's the shoot command that created it. Maybe zoom in when it's 14 here. That should be okay. Yeah, so now we have that. Next, we need to cut turn off our section view again. We need to cut this ejector pin so they appear at the correct length. So this is the surface command. I said this, said this. Okay, so again, offset, we will have offset it initially, but anyways, 0.3, offset, that is 0.3. We don't want it to enter into the parts too much. So now we can use this study command. Let's select this one. Hold down control. Select this one. Select this one. Select this one. Yeah, 10 number. Select this one. The splitting tool. Reading. We can't merge all of them together. So we created them separately. Yes, so it's triggered separately, but they are not merged together. So you have to beat. You can't do everything at once. Otherwise, we have a error. So let's select This one will be once on display. Split into this. Let's select the album area. Now, so that's done. Do it for this one as well. Select this one, select this one, select this one. You need to extend all this way, just it cuts that as well. Now we'll do it for the other cavity. So, this we are done. Now, so next we're going to do is select the bodies, hold on control. Let's select this one. Another one again is the surface is selected. Oh, so let's try it. If I delete, let's see. Now, so it selected the surface, not the body. So we have to remove it from the browser. So think, what is this? So think the second one is the other one to remove. So we have to open all of this. Now we can select each of them. I have to select 20 of them. And make sure we'll confirm if the top one is moving. Still hold down your control. Remaining one. Also, all of them. So let's click remove. Let's see. Or ejector pin. Let's hide the surface because the ejector pin is supposed to protrude out a little bit. If it's inside, means you have to rework it. Yeah, so well, it's protrudes out. It protrudes out a little bit. So now we have our ejector pins. We have our whole ejector pins fitted. So in the next episode, we'll move the part to placing the die springs for the ejector pins.